Today we're going to talk about coterminal angles and reference angles. So before we get into that, we're going to review a little bit of what we talked about previously about what standard position of an angle is. So in standard position, we say that the initial side is the positive x-axis. And then in terms of rotations, when you rotate counterclockwise, you get a positive angle measure, whereas if you rotate clockwise, you have a negative angle measure. And so here's just a picture of what we're talking about here. The initial side is on the positive x-axis, as you can see on both of these diagrams. And then in the first one, you can see that we're starting by rotating counterclockwise. So as you start going up from the initial side, that's going counterclockwise. That's going to be a positive angle measure. In the second diagram, the initial side you can see gets moved starting down, and that's going clockwise, and that's going to give you a negative angle measure. Now, angles are going to fall in one of the four quadrants, so just as a reminder of which quadrant is which, we start in the quadrant that has both x and y being positive as quadrant 1, and then we rotate counterclockwise and we number our quadrants that way. So quadrant 1, 2, 3, and 4 as you move counterclockwise. Okay, so first let's talk about coterminal angles. So coterminal angles are angles that have the same initial and terminal sides, but you rotate them differently in order to get there. So here's an example. Let's say we have an angle measure here. Let's call that pi over 3. And okay, so pi over 3, I know we're gonna get used to using radians, but if it helps, we can write down what the degree measure is over on the side here. So pi over 3 radians is the same as 60 degrees. And so a coterminal angle would have the same initial and terminal sides, but in order to get there, we rotate differently. So for example, instead of rotating counterclockwise, we could have rotated clockwise to get there. Now, if we rotate clockwise, this would be a negative angle measure. And how much have we rotated? Well, if you want to think about it in degrees, since you may still be more used to thinking about things in degrees than radians, think about, well, how many degrees do I need in order to reach 360 degrees? Well, if 60 degrees is already accounted for here, then it must be 300 degrees, but it's going to be negative because we are rotating clockwise. So this is going to be, in radians, negative 5 pi over 3, or in degrees, negative 300 degrees. Now, it's not just two different ways that you can rotate in order to get there. You could also rotate a full rotation. Let's rotate counterclockwise, a full rotation, and then a little bit more to get to that terminal side. So something like this. Now that is going to be what? That's going to be, let's think in degrees, 360 degrees plus another 60 degrees. So that's going to be 420 degrees. In radians, that's going to be 7 pi over 3 radians. So another way to think about how we are actually getting these other coterminal angles, well, all you have to do is add or subtract one full revolution, whether that's 360 degrees or 2 pi. So if you start with 60 degrees, you subtract 360, you get negative 300. You add 360, you get 420 degrees. If you work with pi over 3, if you add 2 pi, you're going to be doing pi over 3 plus 6 pi over 3, which is 7 pi over 3. If you subtract 2 pi, you would be doing pi over 3 minus 6 pi over 3, which would be negative 5 pi over 3. So either way, you are adding or subtracting one full revolution or one full rotation. Let's do example 1. It says, give two coterminal angles, one positive and one negative, for the given angle, 11 pi over 6. Let's start by drawing 11 pi over 6. Now we want to get used to using radians and not having to convert back and forth from radians to degrees, because otherwise, if you're trying to give an answer in radians, you'll have to convert back from degrees into radians. So let's start thinking about it this way. Remember when we talked a little bit about radians and how we convert, we talked about how a full rotation is 2 pi and half a rotation is going to be pi. So let's start there and start thinking about everything in terms of fractional parts of pi. Now 11 pi over 6 is just short of 12 pi over 6, which is 2 pi. So it's just a little bit under 2 pi. Now since one full rotation is 2 pi, 11 pi over 6 is just short of a full rotation. So we're going to be in quadrant 4. Now really the important thing here is to know which quadrant you're in, not to be as accurate as possible when you're drawing the terminal side. The more that we do this, you'll notice that I'm more concerned with you knowing which quadrant it will be in. So that's 11 pi over 6. And now we need to find two coterminal angles. One is going to be positive and one is going to be negative. Let's start with the positive one. So for a positive angle measure, what we can do is we can add a full rotation. So notice here I've gone from the initial side to the terminal side, and then I added one more full rotation. So what we're really doing is we're doing 11 pi over 6 plus 2 pi plus one full rotation. So that's 11 pi over 6 plus 12 pi over 6. You get the same denominator in order to add those fractions, and that gives us 23 pi over 6. Okay, so that's a positive coterminal angle. Now for a negative one. To get a negative angle measure, we take the initial and terminal sides and we get there by rotating clockwise, like that. So in terms of what you're actually doing mathematically, you are just subtracting 2 pi from 11 pi over 6. So 11 pi over 6 minus 2 pi. So 11 pi over 6 minus 12 pi over 6, and that comes out to be negative pi over 6. So we have successfully found two coterminal angles, one that's positive and one that's negative. Let's look at the next example. What angle in the first revolution, so in other words between 0 and 2 pi, is coterminal with 19 pi over 3? Okay, so what we want to do here is we want to simplify this angle measure as much as we can until we have an angle measure that is between 0 and 2 pi. Now 19 pi over 3, we have to determine, is that between 0 and 2 pi right now? If you're not sure, think of it in terms of a fraction, right? 19 thirds. No, 19 over 3 comes out to be 6.3 repeating times pi. So that's definitely over 2 pi. So in order to get an angle that's coterminal, we want to keep subtracting 2 pi until we get a value between 0 and 2 pi. So let's go ahead and do that. So 19 pi over 3 minus 2 pi, that would be 19 pi over 3 minus 6 pi over 3, which is 13 pi over 3. Now 13 pi over 3, ask yourself again, is that between 0 and 2 pi? Well, 13 divided by 3, that comes out to be 4 point something times pi. So again, it's not quite between 0 and 2 pi, so we're going to have to subtract 2 pi again. So 13 pi over 3 minus 6 pi over 3, which is 7 pi over 3. Looks like we're almost there. So 7 pi over 3, we have to subtract 2 pi again. And then this comes out to be pi over 3, which is between 0 and 2. And 1/3 of pi is in fact between 0 and 2 because 1/3 is between 0 and 2. Now, if we're, as you're getting more used to this, you might realize, okay, 19 pi over 3 is way more than 2 pi, and I would have to do this multiple times. You can absolutely feel free to subtract any multiple of 2 pi, so instead of subtracting 2 pi, you could subtract 4 pi or 6 pi if you know that the angle measure you're given is way more than 2 pi. Okay, so that's coterminal angles. now we're going to talk about reference angles. Now, a reference angle is the acute angle that's formed by the terminal side of an angle and the x-axis, and it's always going to be positive. So, just so we can see it in all four quadrants, here it is in quadrant 1. So if you have a terminal side in quadrant 1, then you just take the acute angle formed by the terminal side and the nearest x-axis, that would be right here. For a terminal side in quadrant 2, right, so we're rotating counterclockwise, but the reference angle is going to be the acute angle formed by the terminal side and the closest x-axis, which in this case would be the negative x-axis. So that would be the reference angle here. In quadrant 3, this is going to be the terminal side and the negative x-axis that forms the reference angle. And in quadrant 4, that would be the terminal side with the positive x-axis, giving us the reference angle. Now remember that the reference angle will always be positive. Another thing is that the reference angle will always have the same denominator as the original angle. So that's kind of a little bit of a hint to help you as you're trying to determine what the reference angle is. Now, as we look at example 3, and we find the reference angles for each of them, we are going to actually draw out each of these angles. It's good practice to know in order to help you figure out which quadrant you're in, especially as we get into finding trig values of different angle measures, and we're going to use reference angles, but we need to know which quadrant it's in order to do that. So let's start with 5 pi over 4. Now again, we're going to try to avoid trying to convert something into degrees and then draw it in and then figure it out and then convert it back into radians. The more we get used to thinking about things in radians, the more it'll actually be easier for us to do these calculations. So 5 pi over 4, let's think of this again in terms of pi and 2 pi. So remember, 2 pi is a full rotation, pi is half a rotation. So 5 pi over 4 is just a little bit more than pi, right? It's 1 1/4 pi. So if we want to think about where this is on the graph, 5 pi over 4 is going to take us into quadrant 3. So this angle here is 5 pi over 4, but here we want to find the reference angle. So remember, the reference angle is the angle that's formed by the terminal side and the nearest x-axis, in this case the negative x-axis. So this here would be the reference angle. Now, what measure is that reference angle? Well, this is the part that comes after pi rotations, right? So half of a full rotation is pi, and this is the part that's above that. So since this is 5 pi over 4, well, how much more do you have to add to pi to get to 5 pi over 4? You need to add an additional pi over 4 to get there. So again, you can notice that for all of these, as we continue, we'll actually have the same denominator as you're working to find the reference angle. Let's look at the second one, 6 pi over 7. Again, let's start by sketching it. So 6 pi over 7, that's almost pi, right? 6/7 of pi. So this is going to be in quadrant 2. This angle here is 6 pi over 7. And so the reference angle, again, is the terminal side and the nearest x-axis. So in quadrant 2, that would be this angle right here. And so you can ask yourself, well, how much more do I have to add to 6 pi over 7 in order to reach pi? In this case, that would be pi over 7. So our reference angle here is pi over 7. Again, notice the denominators are the same. All right, last one, negative pi over 3. Now remember, with negatives, that means we are rotating clockwise. So negative pi over 3, so 1/3 of pi would be less than 1/4 of a turn, right? So that's 1/3 of pi. So think of it as, okay, pi is half a rotation, so 1/3 of half a rotation should only take me to that first, into one quadrant. So we know this is negative pi over 3. Now this one, the reference angle, is the terminal side with the nearest x-axis. So this happens to be this same angle measure, but remember that reference angles are always going to be positive. So the angle measure here is going to be pi over 3.